question 20. Question 20 is actually testing students on the topic of periodic table, okay, the properties of elements in the same group. Okay, so let's take a look at the question. Sulfur and selenium, they are in the same group of the periodic table. From this, what will be the formula of the compounds formed with selenium? All right, so if they are in the same group, sulfur and selenium, they are in group 6. Okay, group 6, so they have 6 valence electrons, and they would have similar chemical properties, okay, which also means that the formula of the compounds that they form, it will be similar as well. Okay, similar chemical properties. Let's determine the formula of the ion first. Sulfur, right? Your ion, sulfur atom, 6 valence electrons, it will gain 2 electrons to form sulfide, SULFIDE, okay, IDE, which means that selenium, it will also, because it has 6 valence electrons, it will gain 2 valence electrons to obtain a complete outermost electron shell, Se2 minus. The name is selenide. Okay, what other ions does sulfur have? We have sulfate ion, SO4 2 minus. So since they are in the same group, we can replace the sulfur in sulfate to form SeO4 2 minus. All right, so these are the two ions that selenide can form based on our understanding that they have similar chemical properties due to the fact that they have the same number of valence electrons. Okay, so whenever you're asked to determine the formula of the compounds, I will always do this by elimination method, and we start off with the ionic compounds first. What are ionic compounds? Ionic compounds, it is the compound formed between a metal and a non-metal. So we look at the calcium selenide. Okay, calcium is in group 2, so it forms an ion with a charge of 2 plus, selenide Se2 minus. So based on the cross method, 1:1, the formula should be CaSe, which means that you can eliminate option 2. Okay, what about potassium selenate, ATE, selenate? Potassium, it is a group 1 metal. All right, it's an alkali metal, so it will lose 1 valence electron to form a cation with a charge of +1, K plus, and based on the formula of selenate ion that we found, SeO4 2 minus, from the cross method, it is 2:1. So the formula of potassium selenate is K2SeO4. Hence, your answer will be B. Okay, because C and D gives the wrong formula of potassium selenate. What about SeO2 and SeO3? These two compounds are actually existing, because I'm sure you have seen sulfur dioxide and sulfur trioxide before. So SeO2 and SeO3 may also exist. Okay, so we do this question by elimination. Okay, hence the answer for this question is B.